Hello everyone. Today I'm going to explain my task M3T2C. In this code, I have implemented k-means clustering algorithm on a parallel computing device using OpenCL for faster execution compared to CPU only implementation. I have used a struct point where I have defined two floating points x and y representing its coordinates in a 2D space. I have also declared generate random points which generates num points random points within a square with coordinates between 0 and 100. And I have also created a srand time null pointer which seeds the random generator with the current time to ensure different random sequences on each run of the program. These lines generate random value for x and y coordinates between 0 and 100. I have used rand underscore max which divides and casts the value which holds the maximum possible value to scale it a value between 0 and 1. For its initialization, I have used OpenCL platform. With those platform, this code typically selects the first available platform and device for simplicity. In this code, I have used const k means kernel source, which is a kernel function which is executed in parallel on multiple processing units of the device. It takes arguments including pointers to the buffers holding the data points and centroids, the number of data points and the number of clusters. Init global work item ID to retrieve the unique work item ID for the current data point being processed in parallel. This ID helps identify which data point this thread is responsible for. I am also assigning to cluster what it assigns the coordinates and what it corresponds to the points buffer. For data transfer and execution, I have used points buffer and centroids buffer in the device memory to store the data points and centroids transfer from the host. For the kernel execution, I have used k means clustering object for compiling the program. I have also used points buffer and centroids buffer and the number of clusters which is launched on the device for all the data points. This instructs the device to execute the kernel function in parallel for each data point, effectively assigning them to clusters simultaneously. And for reading the results, I have after the execution is complete, it will refer to the points buffer which refers back to the host points vector using the command queue. This updated points vector now reflects the cluster assignment for each data point based on the closed centroid. Now I am going to describe the main function which defines the number of data points which is num points and clusters for the k-means algorithm. It calls generate random points to create num points, random points and num clusters initialize centroids. Calls k-means clustering OpenCL to perform the k-means clustering using the defined data points, centroids and number of clusters. For additional considerations, I have used k-means clustering which is based on Lloyd's algorithm. It assumes a data point that reside in a Euclidean space x and y coordinates. K-means is effective for spherical or blob shaped clusters. For error handling, I haven't used specifically, and this is my code explanation. Now I will show you that how my output is working based on this code and show the out execution time which would be printed. So here is my execution time and it is mentioned. Thank you.